Corals are very important organisms in our ocean that can live for thousands of years. Many species, including millions of people around the world, depend on coral reefs for food, medicine, protection, and jobs, and nearly 25% of the world's fish rely on coral reefs for food and places to live. Corals are colonial animals, meaning there are many individuals who live, grow together, and need one another for survival. The individual animals within these colonies are called polyps. Each polyp has tentacles, or stinging cells that can capture small particles of food, remove debris, or even attack and sting nearby corals in order to make room to grow more. We call these tentacles nematocysts. Each polyp only has one way for food to enter and exit. Food is captured, eaten, and pooped through the same opening. Depending on the size and species of the coral, they can eat tiny things like microscopic zooplankton all the way up to larger things like small fish. There are over 6,000 identified coral species found around the world, growing in warm, shallow waters near coastlines, while some live on the seafloor of the open ocean where it's dark and cold. Our coastal reefs are very important. They help protect our Earth by absorbing large amounts of carbon dioxide in the air that contributes to climate change and regulates the temperatures of our oceans and the land. They are responsible for protecting us from large waves, storms, and floods that cause erosion and destroy homes and people's land. Coral reefs reduce wave energy by 97%. The different formations corals make help break up the waves before they hit the shoreline. As our reefs are impacted by climate change, the weather and storms are getting stronger, hitting the coastal communities with flooding, causing damage and many lives and homes lost.
Of 130 miles per hour. The sprawling mass of Helene, a jaw-dropping 500 miles in diameter. Already tonight, some dramatic images of the storm surge, water rushing beneath Florida's Matlacha Bridge. A storm surge of up to 20 feet forecasted. Virtually the entire west coast of Florida under hurricane and storm surge.
We have already lost half of the world's reefs, and scientists predict we could lose up to 90% if actions are not taken to protect them. Corals face major threats due to human activities, such as poor tourism and fishing practices, allowing anchors to be dragged across the ocean floor, destroying everything in its path.
Looking at new video of the damage an anchor caused along Horseshoe Reef at Kewalo Basin. The DLNR says 200 coral were impacted and teams found 2 scars from an anchor drag that measured about 80 feet long. Crews were able to put back a little less than half of the coral impacted. The next step is to look at long-term remediation and restoration.
Overfishing areas can be harmful by disrupting the population. With less fish to feed on algae, the algae can grow over the coral, killing them. Nets, hooks, and other equipment get left behind by fishing boats. These can damage the reefs and entangle wildlife. And a technique many fishermen use, known as blasting, which is particularly damaging to the corals, causing them physical damage.
The shockwave that goes through the body is quite enormous. And to think I was probably 40, 50 metres away from where the blast happened, so it's no wonder it does kill a lot of fish.
The damage from these blasts leaves nothing but rubble and bleached dead coral in its path. Coral bleaching can also be caused from other factors as well.
Coral bleaching is caused by heat stress. The coral expels the tiny algae, providing the colour. These mass bleachings are becoming increasingly common. This is the Great Barrier Reef's 5th such event in just 8 years.
What that's actually really telling us is that the science has been very clear for some time that the global temperatures are increasing as a result of our changing climate.
And the signs globally, over the past year in particular, have been ominous.
Places like Southeast Asia and the Caribbean are the biggest problem. Philippine reefs are in really bad state. The Japanese reefs, particularly those around Okinawa, are gone. Many of the reefs in the Caribbean, Jamaica, Haiti, Dominican Republic, they're in really bad state. I'd add to that Florida, Sri Lanka, India, the east coast of Africa, those reefs are in bad state. Basically because people are overusing reefs and exploiting them too heavily. There's too much stress on coral reefs by human populations.
Grecian used to be a vast coral gardens from one end to the other. Beautiful, beautiful elkhorn coral, particularly on the southern end of Grecian rocks. Now there today, the elkhorn coral is still there, but it's skeletons. It's all dead and taken over by algae.
About 20 feet from the beach was a lot of life. You had sea fans, coral, sea urchins, white sea urchins, black sea urchins, and all that's disappeared now.
It does make you want to cry. I mean, you feel you're hurt inside, that's all.
The planet is warming, but it's also simultaneously being enriched with reactive nitrogen.
Nitrogen that comes in part from what's driving climate change, fossil fuels. Nitrogen also from agricultural runoff and in untreated wastewater.
Nutrients in the form of synthetic fertilizers containing nitrogen and phosphorus, when added to agricultural land, can leach into rivers and ultimately the sea. Other sources of these include human sewage and farm animal manure. These nutrients can cause an explosion of plant and algal life that disturbs delicate marine ecosystems.
Pollution comes in many forms. The effects can take away the oxygen in the water, making the water very murky and allowing the spread of bad bacteria and disease that affects reefs, seagrass beds, and mangrove forests. When this happens, it can be deadly to many forms of marine life. It's estimated that there are 700 dead zones now in the ocean due to these issues. Oil spills are another deadly form of pollution affecting corals in our ocean. It blocks out the sun that corals need to help them grow. Toxic chemicals in the water from this pollution can be harmful to all types of life, and certain metals, like copper, can be deadly to corals and invertebrates. Even things like sunscreen and pesticides can be harmful pollutants. Another issue corals face is trash. Large amounts of trash can entangle and break coral.
American oceanographer Charles Moore first encountered the garbage patch, also known as Trash Island, in 1997 when returning to California after finishing the Los Angeles to Hawaii Transpac yacht race, and reported that it took him 7 full days to cross it. 20 years later, and this monstrosity measures around 1.6 million square kilometers and contains approximately 80,000 tons of plastic. That's over twice the size of Texas and 500 times heavier than a house. A surprising thing about this area is that despite its size, it is virtually invisible to satellites and aircraft. This is because 94% of it is made up of minute fragments of plastic called microplastics. This complicates any location and cleanup process because it means the plastic can only be located and retrieved by boat. These microplastics measure just a few millimeters in diameter, which also makes it very hard to remove them from the ocean without removing a large amount of important sea life with them. Another thing that complicates this cleanup process is that because this plastic island is out in the middle of the ocean, miles away from any land, no country will accept responsibility for its cleanup. And with no funding, it is just left to grow. Perhaps the most troubling thing about this floating island of trash is that it isn't unique. There are similar garbage patches in the North Atlantic, discovered in 2009, the Indian Ocean, discovered in 2010, the South Pacific, discovered in 2011, and the South Atlantic, discovered in 2017. There was even one discovered fairly recently in the Mediterranean Sea.
We can find plastics in local coral colonies, and they were at numbers that were much higher than we expected.
Reef ecosystems support 25% of the ocean's biodiversity, so it's important that coral stays healthy. Students feed them plastic blue microbeads, similar to what were once used in personal care products. The coral easily ingests the beads.
When we give them choice between plastics and natural food that is the same size and same shape, overwhelmingly, they choose the plastic.
The concern is that small organisms eat the plastic, and that goes up through the food chain to plankton, other fish, and eventually to humans. It's not just the plastics that are a concern, it's bacteria.
One of the findings that concerned us the most from this work was that we were able to show that bacteria that are on the surface of plastics indeed ride in on those plastics when they're accidentally ingested by the corals.
Degraded plastics and microplastics, like beads and soap, can be consumed by coral, fish, sea turtles, and other reef animals, blocking their digestive tracts and building up harmful toxins in their bodies. With corals being threatened in many areas of the world, it's more important than ever to help rebuild the reefs and protect them. The loss of corals means the loss of fish, turtles, sharks, dolphins, and many other animals who rely on a healthy reef. When I was younger, I always loved the ocean, and in particular, sharks. I knew I wanted to be a marine biologist, so I went to college over in Hawaii. During the time I was there, I watched many sections of the coral around the islands die, and the impact it had on the entire island, not just the animals who lived there. One of the major things I saw was a decline in shark populations, who need a healthy coral reef to provide food for them to eat. If there are no predatory animals like sharks around the reef, then fish can overpopulate, and some fish can eat coral. If their numbers get too large, they could eat the corals faster than they can grow. Sharks are important in maintaining a balance, and seeing how important each species is for one another's survival, I knew that if I wanted to save the sharks, then I needed to help save our coral reefs. I first took an internship working with sharks, stingrays, fish, and turtles. Worked on a dive boat getting my certifications, and then I later took an internship in water quality, learning about the animals and equipment needed to care for them in captivity. While in college, I took on a project studying a zooplankton we called dinoflagellates. We call them dinos for short. There are at least 1,000 dinoflagellate species that have been observed. Some can be good, creating a unique relationship that benefits other organisms, such as jellyfish and coral, who rely on its help to both produce food and be a part of the food chain directly for other animals in the ocean. Corals can't photosynthesize on their own. They need a specific microscopic algae we call zooxanthellae, and it lives within the coral's flesh to photosynthesize and provide food. Having different ways to eat and provide food helps each coral have a better chance of survival. But sometimes when the environment becomes off-balanced, conditions can allow certain species of dinos or even bacteria to overpopulate, and when this happens, it can be toxic to marine life and often looks like a brown, bubbly slime algae that smothers corals. This can happen out in the ocean when different types of pollution mess up the ocean's balance. For many people starting aquariums at home, these toxic blooms can occur more frequently, killing the corals and fish we enjoy keeping. I wanted to find natural ways to battle common issues in the aquarium to help balance and create a natural ecosystem. One of the ways to do this is through the use of good zooplankton we call phytoplankton. There are many types of phytoplankton, but we chose 3 to work with and observe due to their nutritional content and growth. When introducing them to our aquariums, these phytoplankton species can help reduce bad algae and the dinos by using up things like food and oxygen, or by helping to feed small invertebrates that will repopulate and help outcompete harmful blooms. While observing how phytoplankton does this, we began to see many other benefits as well. Each cell of phyto is packed with proteins, and these proteins can be used by corals to grow brighter flesh and grow faster. Phytoplankton makes up a small portion of zooplankton that is the foundation to all marine life, being eaten by the smallest of invertebrates like small shrimp, snails, and other filter-feeding animals, and can also sustain enough food for large animals like the whale shark and manta rays who rely on these blooms for their food. In the ocean, phytoplankton blooms are very important, not just as a food source, but also for a large portion of the oxygen that we breathe. Phytoplankton is also photosynthetic. During this process, it absorbs carbon dioxide from the air and releases oxygen. Phytoplankton blooms are responsible for about half the air we breathe and helps combat greenhouse gases as well as regulating the ocean's climate. Seeing how important both corals and phytoplankton are to helping keep our oceans safe and balanced, I took what I learned after I graduated and began building our small facility in 2019. In 2021, my partner Paige and I quit our jobs and opened KMP Aquaculture. We wanted to be different than many others in this business and only provide corals that have been grown in aquariums to help reduce the damage we do to our wild reefs. There are many species of coral that have been aquacultured now for the last few decades thanks to the dedication of both hobbyists and scientists. In doing this, we have found the corals to grow better and faster than compared to their wild counterparts. They are more resilient to changes and help reduce the amount of harmful pests passed around. Another major issue people face when keeping aquariums is the spread of harmful organisms that come in from the wild corals. The ocean has such a diverse ecosystem where many pests are consumed by fish and other animals, so their effect is minimal on a coral reef. But in our tanks, they often have no predators, so they can reproduce quickly, wreaking havoc on the corals we grow. If not treated, the corals will die. These pests are spread with the passing of corals from one aquarium to the next. By only having aquacultured corals and having a quarantine system, we prevent pests from spreading any further. Someday we plan on using our clean, pest-free corals to rebuild coral reefs around the world, but in the meantime we provide corals and live foods like the phytoplankton to anyone who enjoys having a coral reef in their own home. We sell the corals on little plugs that allow for easier shipment and movement to minimize damage on the coral's flesh. We call these plugs frag plugs. They contain a small piece of the coral we have cut and allowed to heal. Depending on the coral, they are cut differently to give each frag its best chance at survival. When cutting a coral, there is always risk of it developing a bacterial infection and dying, so we have developed techniques that help them heal quickly and treat for infection if needed. We break corals down into 3 general categories. Soft corals are corals that contain no hard skeletal base. They are the easiest corals to keep and often grow the fastest, spreading over rocks and rubble. LPS, or large polyp stony corals, meaning they have large polyps attached to a hard skeleton. And SPS, or small polyp stony coral. These are the typical hard stick corals we usually see around the coast. They can stretch up like trees towards the sun or grow out on the rock, spreading out to get as much light as possible. These are harder to keep in our aquariums and rely on stable conditions to grow. Corals are vital for all life on Earth, and it's more important than ever that we all do our part in preserving these amazing species. Even if you aren't growing corals on your own or replanting them on the reef, there are things everyone can do to help. Like picking up trash you find on the ground to keep it from ending up in our oceans, and helping stop the use of plastic by using paper straws and plant-based products instead of single-use plastics, using energy-efficient lighting, driving eco-friendly vehicles, using natural pesticides and fertilizers, and even reducing the amount of water we use when showering or washing our hands. It's also important not to touch or bother wildlife around you, or you can even help by donating to establishments like us who are working hard to preserve coral for future generations. And last but not least, spreading the word on the importance of corals for our oxygen, medicine, food, and jobs all around the globe. Thank you all so much for having me and allowing me to speak to you guys today, and if you guys have any questions, please feel free to ask.